Hi everyone, I am Dr. Juie Shetye from the Department of Astronomy at New Mexico State University. This is a short presentation of how the sun looks like and what I do to observe the sun. So I look at the sun using telescopes, and I am joined by Heidi Sanchez, who's going to tell us a little bit more about the wonderful outreach that she's doing at the Sunspot Solar Observatory. Her outreach combines art and fun and the sun. So let's begin our journey. So here are the telescopes that I have visited throughout my career. On the left, on the right, you have the futuristic telescopes. The ones on the left are classified as 1 meter class telescope. On the right, those are 4 meter class telescopes. So they have 4 times more power to collect photons. At present, I work in the Department of Astronomy at the New Mexico State University. This department looks after the Dunn Solar Telescope, which is one of the oldest telescopes that scientists have used to understand the solar atmosphere. And it has different instruments that look at different regions of the solar atmosphere. Let's think about this. So, does the sun have the atmosphere similar to Earth? And I would say yes and no. The sun has an atmosphere similar to the Earth's atmosphere in the sense that as Earth atmospheres has different layers, the sun's atmosphere also have different regions. And those regions are separated by different properties. This movie is constructed by UCLAN using data from the Solar Dynamics Observatory. And this movie shows you different regions of the solar atmosphere. Now, on the left, the yellow color corresponds to the photosphere, which is the surface layer of the sun. The next one is also photosphere, but a little bit hotter than the surface. In the photosphere, you see some dots, and these are the black dots that you see here. They are the sunspots. We are going to zoom into one later on, so let's not get into the details of those. As you go away from the surface of the sun, the solar atmosphere becomes hotter and hotter. And here you have the chromosphere. The red color corresponds to the chromosphere of the sun. From the chromosphere, you enter the transition region, and from the transition region, you enter the hot corona. So what you can see from this movie, I'll play it again, is that the sun looks very different at in the different regions of the solar atmosphere. In some regions, it looks like it's a boiling gas of fire who's going to erupt. For example, have a look here. This part has been taken at 1.2 million kelvins. So that's 1.2 million degrees Celsius too. So that's very hot. If you compare that to water, boiling water is 100 degrees Celsius. So I use the telescopes that are available to me. Now, this is an image from the Daniel K. Inouye Solar Telescope, which is in Hawaii. So with the telescopes, we zoom into small sections. It's like looking at microorganisms using microscopes. So I'm zooming into small sections of the solar surface. Now let's dive into the solar atmosphere. In this movie, I'm going to show you what a solar scientist sees when they look through the solar telescope. Okay? This movie was constructed from one of the data that I took from the Big Bear Solar Observatory. And we have zoomed into a sunspot here. You could fit in 3 Earths in this sunspot. Now, the sunspot has different regions. My mouse is pointing at the umbra of the sunspot. The penumbra is the outer region of the sunspot that covers the umbra. And between the two sunspots, you get this bridge like structure, kind of it's joining the two sunspots. And that's called as the light bridge. Why does the sunspot look darker than the rest of the surface? And that's because the sunspot is at much lower temperature than the surface of the sun. When we are not looking at the sunspot, we look at these patches, and they look like patches on the solar surface. These gray patches are called supergranules. Sometimes at the edges of the supergranules, you get magnetic field concentrations. Now, when I play the movie, you're going to see everything wobbling. It's almost like you're boiling cheese in these regions. At this point in the movie, we are seeing the lower end of the solar chromosphere. And we have traveled less than 500 kilometers above the surface of the sun, and you see completely different dynamics of the solar atmosphere. So you see long dark structures here, and you see some jets coming from the light bridge. You also see that many of these patches now have these bright regions. So the edges of many of these supergranules are now showing some brightenings. And those brightenings are nothing but eruptions that occur because of large concentrations of magnetic field. This is the upper end of the chromosphere. And we see something completely different from what we saw 10 seconds ago in the lower end of the chromosphere. So here you see much more structuring. And this is all solar plasma. And this solar plasma is flowing along those field lines and falling into our sun. And the sunspot now looks completely different from what we saw in the photosphere. When I play the movie, you actually see some pulses. It's like the sunspot has some heartbeats and it's beating rhythmically. Let's see the movie again. And we start at the photosphere, we travel to the lower solar atmosphere, and you completely see something different. And this is the upper solar atmosphere. And this is only 1,000 kilometers above the solar surface. So within 1,000 kilometers along the solar surface, we have seen completely different dynamics inside the sun. So now we are going to dive into the solar photosphere. This is a movie from Daniel K. Inouye Solar Telescope. Now, this is how the sun looks like when we use a 4 meter class telescope. These patches that you see, it's like boiling cheese. Now, what's happening here? So, inside the solar surface, you have convection currents. Those convection currents transfer the hot fluid inside the solar surface on the surface of the sun where it cools down. So the hot surface would come emerge in the middle and it would spread to the edges of these supergranules and it will fall down back inside the sun. I'm going to show you how you can create the surface of the sun at home. So this video is from Trishana Ben at the National Solar Observatory placed at Inouye Solar Telescope in Hawaii. Yeah. So let's watch her.
You'll need a hot plate safe glass or metal dish or pot. And you'll need about 2 tablespoons of mica powder, also known as pigment powder. This is what I use. And you also need about 2 cups of vegetable oil. Just a quick note on safety is that this demonstration involves the heating of oil, so hot surfaces and hot oil. So be sure to ask an adult for help before beginning this demonstration. Add your oil. I just kind of eyeballed it. Then your powdered pigments. Give it a stir until it looks something like this. Turn the heat up until you start to see convection cells form. Once those cells have formed, you can actually remove your dumpling from the heat. Because the bottom of the dish will still be hot, you will still see these convection cells. So this is a great fluid, not just for showing convection, like what happens on the surface of our sun, but for showing any types of currents through fluids. You can see those convection cells start to form again. Does it look like what we saw on the surface of our sun?
In that video, you use art to explain convection. Now, at the Sunspot Solar Observatory, we use art and different experiments to explain different aspects of not only the sun, but in general, physics. So I'm going to let Heidi Sanchez from the Sunspot Solar Observatory tell us a little bit more about the outreach events that she organizes, which combine art, fun, and learning about the sun.
Hi, my name is Heidi Sanchez, and I am the Education and Public Outreach Coordinator for Sunspot Solar Observatory. It is with great pleasure I share this video with you to showcase how the observatory is engaging our community. From the pictures you will see, we offer more than you would expect. Our programs provide kids and families an inviting way to learn STEM content through informal STEM activities. Activities which encourage participants, young and old, to explore, activate their curiosity, and discover new things. We paint the moon, explore making a simple circuit that lights up an LED light, design galaxies, celestial objects, and planets with glitter and glue, create sun art with sun-sensitive paper. We produce marble paper with shaving cream and construct a constellation projector. We had fun learning about the moon phases by stepping inside the moon phase transporter to be immediately taken to the view from Earth. We test sunscreens with UVB, create outer space scratch art. We even teamed up with a local pottery shop and invited the public to make Sunspot Solar Observatory coasters using custom molds. And yes, we even fit in time to learn about the sun. Thank you, and I hope the next time you find yourself in our area, you will pay us a visit.
That was a little bit of introduction of the sun, the surface of the sun, and what we do at the new at my at the Sunspot Solar Observatory, which is my new home, which will be my new home. I hope you enjoyed this video. Thank you. Take care.